So in this video I want to try to explain this thing called the empirical rule and explain where do these numbers 68, 95, and 99.7 come from. They're numbers that you will memorize. And so what we first have to look at is a normal curve. Now let's talk about what is normal. Let's make sure we understand normal. Normal just essentially means it's a balanced distribution where the further a value is from the average, the less frequently it occurs. And we can think of scenarios where this occurs. Height is one example, right? If there's the average height, and the further someone gets away from the average height, either short or tall, the less frequent those people become. All right, so that's exactly what a normal distribution means. So let's use this example of height to talk through just a real basic scenario of how we can analyze the normal curve. Now, if we cut the curve in half right here, right, and we go right through that middle of the curve right there, that point right there is going to be, on a normal distribution, it's the mean, it's the median, and it's the mode all at the same time. It's all three values at once. Let's talk about them in reverse order. It's the mode because on this left-hand axis we have the frequency. So through this value here, whatever this value of height is, remember mode is the most frequent thing, right? So this is has the highest frequency at the peak of the curve. So that's why it's the mode. It's the median because since this curve is symmetric through this line, if I chop it in half, basically 50% of people are less than the average height and 50% of the people are greater than the average height. That's a pretty basic thing to say, but it is very true. When you take half the people are taller than average and half the people are shorter than average. So that's why it's the median, because the median cuts things in half. It's the mean because of this symmetric nature of the curve. All right, let me try to explain. If I have a person whose height is down here, let's say 6 inches below the mean, right? They're negative 6 inches from the mean. That frequency of that value is whatever that number is there, right? And if I go over and I go 6 inches in the positive direction, so someone's 6 inches taller than the average height, it's that same frequency, right? And you may not understand that fully mathematically as far as a mean, but it's fully balanced. So if there's just as many people 6 inches above the mean as there are people 6 inches below the mean. And if you take the average of those numbers, then the mean will be centered right on this number here in the middle. All right, think of the mean as kind of where's the balancing point. If this thing were a balance beam, it would pivot on that point there, and it would be perfectly balanced to the middle of the curve, and that's essentially what a mean is. Now let's talk about it in terms of a different scenario. Let me come up with a different scenario for IQ. So with IQ, the score is typically with a mean of 100 and a standard deviation of 15. So what that tells me here is that if I dissect my curve right here through the middle, that tells me that that value right there is going to be 100. That's the mean. Now standard deviation talks about how far spread out the data. Let me give you some scenarios for standard deviation. So here's a couple of scenarios. Both these distributions here are normal, but this one you can see is much lower and wider, and this one's kind of tall and narrow. All right, so what we would say here is they're both normal, but this one has high standard deviation. There's a lot of variation between the values, right? Because there's some people way over here and there's some people way over here, and they're very spread out. Now this one, if the mean goes through the middle, then this one has low standard deviation because it varies less. The curve is more narrow. So just remember that standard deviation indicates how much separation there is between each value and the mean. So these are very close to the mean and these are far away from the mean. Now here for the empirical rule, let's finally get to the empirical rule. The empirical rule says if I take the mean plus the standard deviation and the mean minus the standard deviation, I'll get a certain percentage of data. And mathematically you can basically show that if you take the mean plus 1 times the standard deviation, in this case 15, you'd get 115. You subtract 15 from 100 and you get 85. Mathematically, you can show that that accounts for 68% of people. So we can apply this rule to say that we're pretty sure that 68% of people will have an IQ between 85 and 115. Now we can extend that by using other multiples of the standard deviation. So if I take the mean plus 2 times the standard deviation, I get 130, and then subtract 2 standard deviations, I get 70. So 95% of people have an IQ between 70 and 130. And then finally, if I do 3 standard deviations in either direction, I get 99.7.